Hi, everyone. Thank you all so much for joining. This is the OpenAQ Global Community Series, exploring possibilities with the OpenAQ Low-cost Sensor Pilot Platform. Next slide, please. My name is Chisato Calvert. I'm the Deputy Director of OpenAQ, and I'm joined today virtually by Jeremy Taub, Executive Director, and Sruti Modekurty, Platform Lead. Next slide, please. A couple of logistics. Since we're joined by folks from around the globe, would love for you all to introduce yourself with your name, organization, and location in the chat box. And please type in your questions in the chat box as well. We'll do our best to answer them in real time. And also please take a moment to answer the poll questions, and we'll also share a reminder about this as well. You'll see the arrow pointing to the poll button in the Zoom link there. Next slide, please. As a brief overview of this community series, I'll be sharing for a couple minutes a brief introduction to OpenAQ, followed by a demo of the OpenAQ Low-cost Sensor Platform by Sruti Modekurty, and a panel discussion with our exciting and inspiring panelists, Lauren Padilla at the Environmental Defense Fund. We also have Michael Heimbinder at HabitatMap, as well as Albert Presto from Carnegie Mellon University and Cindy Message at Purple Air. Next slide, please. So as a brief overview of OpenAQ, we really see our role at OpenAQ as connecting air quality data and community together to fight air pollution. We developed the OpenAQ platform, which is the world's largest open source real-time and historical air quality data platform. We collect reference grade as well as low-cost sensor air quality data. And by providing this foundational data infrastructure, what we're able to do is connect diverse stakeholders from scientists, journalists, educators, entrepreneurs, policymakers, and community activists to really have that access to basic data that's required to further awareness raising around air pollution and to develop innovative solutions to combat air pollution. Next slide, please. So I wanted to just share the motivation behind actually developing this low-cost sensor platform. We did this in close collaboration with the Environmental Defense Fund. Three areas in particular are to enhance data access, increase data coverage, and promote data transparency. On the enhanced data access piece, this is really an equity issue. You shouldn't need technical expertise to access basic data about the air quality that you're breathing. Everyone, especially people that are living in communities that bear the biggest burden of air pollution, should be able to access air quality data so that they can take action. And so we developed this low-cost sensor platform because we believe that low-cost sensors play an important role in democratizing air quality data, putting air quality monitoring into the hands of citizens that can actually catalyze change. In increasing data coverage, we published a global state of play report in July 2020, and we found that only 51% of governments around the globe produce air quality data, which means that 103 governments don't produce air quality data. And so by building this low-cost sensor platform, what we're hoping to do is actually fill those important data gaps, particularly in the global South, low-income communities, and communities of color. And we see also the potential of being able to use low-cost sensors for more hyper-local measurements at the neighborhood level, as well as including mobile sources that can actually provide new insights that just wouldn't be possible with solely just reference grade monitors. And on the promote data transparency piece, we really believe that collecting and producing air quality data is just one part of the equation. We need to share that data openly in order to spur collective action and ensure public accountability. And so through this low-cost sensor platform, we hope to encourage governments and other private sector companies to really open up their data and join this collective fight against air pollution. So this webinar is designed to aim, the aim is essentially to shed light on the potential of this low-cost sensor platform and also hear from our amazing low-cost sensor partner panelists, Environmental Defense Fund, HabitatMap, Carnegie Mellon, and Purple Air. So I will now turn it over to my colleague, Sruti Modekurty, who will share more about the low-cost sensor pilot platform. Sruti?
Thanks, Chisato. So I'll be giving a brief demo of some of the new features that we have as part of the low-cost sensor pilot platform. You can find more details in some blog posts that we've written, and we'll share links to a lot of the stuff that I'm talking about in the chat as well, so you have access to it. So a brief overview of the exciting stats that we've seen actually with the low-cost sensor platform. So before we had, this was the total number of countries, locations, measurements with just reference grade data on the platform. So we had just shy of 100 countries, over 11,000 locations, and 800 million measurements. And with the addition of the low-cost sensor data, we, with 4 low-cost sensor partners, we have added 21 countries. So we're up to 120 countries now represented on the platform. We've doubled the number of locations and more than doubled the number of measurements. We have over 2 billion measurements, and that's with just like 2 or 3 months of low-cost sensor data that we've added onto the platform since we started working on developing the pilot. So really exciting to see that not only are we filling in data gaps, but we're able to bring greater frequency to the data that's available on the platform as well. So just to look at a side-by-side comparison of the data gaps that we've been able to fill in. So on the left is what the platform looked like with just reference grade data. So this is the continent of Africa, and you can see that there are large data gaps. There are, on the right is with the low-cost sensors added in, still large data gaps, but there are a lot of countries now that do have sensors in them, particularly in West Africa. Similarly, here is Central and South America. You can see that we have greater data coverage in Central America and parts of South America over here as well. Similar thing with Southeast Asia. Before it was like mostly China. China has an extensive reference grade network, but not so much in Southeast Asia. But with the low-cost sensor data now, oops, let me go back for a second. You can see that in Southeast Asia, Malaysia, Thailand, you have at least low-cost sensor data that you can to get a sense of air quality in those countries. Still lots of data gaps to fill in, but we are seeing that with the addition of low-cost sensor data, that there are a lot of important data gaps being filled in. So a brief overview of the new and different features with the pilot platform. So we've expanded the data type definitions a little bit, which I'll talk about next. We have dashboards now on the website to help you explore the data before you actually downloaded it and explore it yourself. You have some visualizations, which I'll show. We also have, we created something called data sets, and this allows for people to analyze data from different sources that have similar characteristics. And then I'll talk a little bit about the API, why there are 2 versions and how to use those 2 different versions, and then talk about how you can access all this data through S3. Okay, so data type definition. So before we just had one attribute that said what kind of data type it was. So it was either government, research, or other. But we recognize that there are a lot of different configurations for how these sensor networks are being set up. So there are, for example, City of London is investing in low-cost sensors, and that's technically a government run program. We also recognize that there are research institutions collaborating with community organizations that use a mix of low cost and reference grade sensors. So we wanted to expand the data type definition so that we can allow for these different configurations and also get some more information about the entities collecting the data and who's ultimately responsible for it. So we've split it up into grade, entity, and mobility. For grade, we have reference grade, which is typical what's been available on the OpenAQ platform. It's collected from a reference grade instrument. Low-cost sensor is, surprise, not reference grade, but it's, generally low cost to manufacture and purchase. And there's, more detailed definitions about what low-cost sensor means in on the GitHub data type definitions page, which there's a link to at the bottom of the slide. I definitely encourage you to check it out. It also has some more resources to like EPA and other entities that have collected more information about what low-cost sensors mean. And then we have entity. So we have government. So this could be a city or a national government. We also have research, meaning research or academic institution, for example, Carnegie Mellon. And then community is anybody else that doesn't fit into those two categories. So this could be a community group. It could be an activist group. And lastly, previously we've only had stationary data, but with the addition of the low-cost sensors, we also have some mobile sensors. And so, stationary means that the sensor is attached to the ground; it doesn't move at all. And mobile is that it means that it could be attached to moving objects, for example, like a bike or a vehicle. And this allows for greater collection of measurements in a certain area. And again, you can check out the more detailed definitions on the GitHub page, but we'll post a link to that in the chat so it's easier to access. And yeah, now we'll go on to the live demo. So this is what the map looks like now. Very exciting. In addition to the reference grade sensors, which are in the which are denoted as circles, you can also get low-cost. You can also see where there are low-cost sensors with the squares. And you can, and as usual, you can check out the different pollutants that we have. So let's say I'm interested in NO2, click on that, and the map refreshes with the locations that have NO2. And then if I were to zoom in and click on one of these, it will give you a little bit of information about that location. So this is Greenville, South Carolina, and you can go and check out the location. So the pollutants that are available here are the core 7 parameters that we have, but with the low-cost sensors, we've also added in some extra parameters like CO2 and VOCs that are available for certain locations, which you can discover in the locations page. So on to the locations page now. Here you can see, we had the locations page before, but it's just a bit revamped, I guess. And here you can filter by country, you can filter by parameter. And here you can see that what are listed first are the core parameters. And then you have the additional parameters that are available for certain locations. So methane, CO2, PM1 count, and several other extra parameters. You can also search by data source. So let's say want to look at all the data in Alabama. You can also search by sensor type. And so this is what I was referring to earlier with the expanded data type definition. So you can say, I want to look at low-cost sensors, and you can select the manufacturer. And then, click on whether you want mobile or stationary, and then select the entity. So let's do low cost, mobile, and community. You can apply that, and you get the list of locations that have, and you can easily see which locations have like which tags for the data types. Oops. And then if you, let's actually get rid of mobile and then click on one of these locations. Let's do Clean Air, Carolina. If you click view more, it'll take you to the location dashboard. And so here you can see the latest measurements. You can see the source, which is coming in from Purple Air. You can see the number of measurements that have been collected, when the data collection has started. You get an overview of all the data points for the past week. And then, you can select one of the other parameters as well, so PM2.5. And then you also get charts about the temporal coverage, so you can see how many measurements were collected for each day of the week or month of the year. And this can help you, determine what percentage of time these sensors were reporting. That can help you with your calculations. If you wanted to get a quick average of the PM2.5, for example, you can go down to the parameters and it'll give you an average and also the number of measurements that went into this count. And then you can also look at nearby locations at the bottom here. So you can see, where is the closest sensor? You can see here, there isn't one for a few miles, but then you can see that there's, more in this area, and you can click on those and check those out as well. Oops. So you can also, the one way to, there are several different ways to access the data for this location. One way is to click download here, and then you can see that it's locations. You can select the country, the start date. Low-cost sensors are only available from starting 2021, but you can say January 4th, an end date. Let's just do week ago. You can select the parameters. So I want PM10 and PM2.5. And then you can download selection, and it will download a CSV file for you. So the other way, popular way to access data is through the API. So you can see that the API docs have been revamped a little bit as well. There are two versions of the API. So this format for the API docs makes it easy for you to test out and learn how to construct queries if you're not familiar with how to use APIs. And so here, let's say that so V1, so let me back up for a second. So V1 is the same API that has always been available. You can only get government grade data through that API. The V2 API is a little bit more optimized, and it has some extra features. So for example, you can get mobile data through these vector tiles. And you would have to use the V2 API to get the low-cost sensor data through the API. So again, V1 for just the regular API that everyone has been used to for the past few years. V2 is a little bit more enhanced, has some extra features, and that's what you would use to get the low-cost sensor data. So let's try it out. So let's say let's just check out the V1 and say that I'm interested in country is Colombia, and then if you execute it, it'll actually give you all the commands. So if you use terminal and you're used to using curl, it'll give you the curl command. If you can also copy paste this request URL so that you can view the data in your browser. So like this, and then you can also see down here actually what it gave back to you. So hopefully this will make it easier for people to play around with the API and learn how to use it if you're not familiar already. And the same endpoints that we've always had latest with the location ID. So one thing that we have changed a little bit is that all measurements are tagged with the location, or all locations are tagged with the location ID. So you'll be able to look up all the locations in an area, for example, get their location IDs, and then search for the latest measurements just with those location IDs. So this should hopefully make it a little bit easier to uniquely identify locations and be able to get specific measurements from those locations. Cities, countries, countries also have an ID to make it easier. Sources, parameters, it's all the same as we had before. So over to the V2 API. So similarly, you have measurements. So let's say I'm interested in, looks like that needs to be updated. We can go over to, let me actually demo it here. So here you can see that you're only getting the government data back because this is the V1 API, but you can use V2, do measurements, and then you'll get back the low-cost sensor data as well. So here you can see this is low-cost sensor, it's entity community, where it is, country, this is PM10 particle count. This is PM10, and you can search, let's say, by entity. So you can still get government data through here. So you can say entity equals government and get just the government data. You could say and is mobile equals true, and it should give back, oops, I might be wrong. Okay, it should be is mobile equals true. The perils of doing a lab demo. Sometimes things don't work out as expected. But we do have a blog post that details how to all the new improvements that we made to the website, as well as the API, and we'll post a link to that so that you can get more details about how to use the API, both versions of the API to get the data that you're interested in. One other feature that we have in the V2 API is we have the averages endpoint, so you can get temporal averages for all the data available on the platform. And the other exciting thing that I forgot to mention about the API is that previously you could only get the past 90 days of data. We expanded that to the past 2 years of data last year, but now with this new improvement, you can actually access all of the data that we have in the archive through the API. So you won't have to use Athena or download files from S3 to be able to access the full archive of the data that we have. So speaking of S3, you can also access the government and the low-cost sensor data through S3. So you can, so the government data you can access through real-time gzipped. This is the URL, OpenAQ fetches.sv.amazon AWS. And this is just like a viewer actually to be able to look at the files. But you can set up scripts to download files from here. So real-time gzipped is where you can get the government data. Click on that, and it'll take you through to the date. Oops. And then go back here. And then let's say you want to get the latest data. So you can go here and click on yesterday's date, and then download these files. Similarly, you can get the low-cost sensor data if you go to LCS ETL pipeline. You have the stations, the metadata, so like the coordinates and other important information about the location is split up a little bit, just to save space for how the data is stored. And then you can go over to measures. You can click on the data source provider, and then you should get a list of all the files. I think it's taking a little bit of time because there are so many files. And yeah, I think that is it. I know that's a very brief demo, but we do have the blog posts that give you some more detailed information about all the features that we have. Lastly, we definitely want you to continue to engage with us. So we have a community survey. We have a, that helps us understand like who's in the community, and really like how can we help you do your job better. And we also have a feedback form specifically for the low-cost sensor pilot. If you have thoughts about anything you've seen today, or any questions, or general feedback, definitely let us know. by filling out that form. We also have office hours twice a month, so that you can get live help from me about, or you can just come in and like share information about like projects that you're working on. It's really kind of a way to get some help, as well as a community kind of show and tell. The next one is next Thursday from 4 to 5 p.m. EST, and you can get the link for that through the Slack. And lastly, if you have the technical skills and you'd like to improve the API or the website, we definitely love your help. As you know, this is an open source project, and we can, there are always things that can be improved. So check out GitHub, github.com/OpenAQ, specifically the repos OpenAQ API v2 and OpenAQ.org. And feel free to ask any questions in the chat. I'll be looking over it and answering questions throughout the rest of the webinar. All right, back to you, Chisato.
Thanks, Shruti. Now we're going to transition into our panel discussion. I'm joined by Lauren Padilla at Environmental Defense Fund, Michael Heimbinder at HabitatMap, Albert Presto at Carnegie Mellon University, and Cindy Message at Purple Air. To open it up, could you share a brief overview of your organization and how you're engaged with low-cost sensors? Michael, can we start with you?
Absolutely, thanks. HabitatMap is a not-for-profit organization. We're based in Brooklyn. And the primary thing we do is we work with schools and community-based organizations to create planning and advocacy maps. And we primarily do that with the aircasting platform. So the aircasting platform consists of the AirBeam, which is a low-cost monitor for measuring PM1, 2.5, and 10, relative humidity and temperature. And then it sends those measurements either into the Android app, where you can visualize them in real time if you're, for instance, using it as a wearable, walking around your neighborhood, or you could also hang it outside your home. Some organizations have created networks of AirBeams that feed the data into the aircasting website. And so the AirBeam has multiple uses. It can be used as a wearable. It can be used as a fixed instrument that communicates over Wi-Fi or cellular. And again, we're really primarily directed, anybody can use our platform. It's open source, our hardware is open source. But from the mission of our organization, we're really focused on environmental justice communities, so low-income communities of color, primarily in New York City, but in the United States. But we've worked with groups all around the world. One thing I did want to share, I wanted to share some work we did recently with an organization called the New York City Environmental Justice Alliance. So I'll put a link into the report that we just released. It's a PDF. And what it shares is the work that we did over the course of around 2 years, where we worked with 6 different community-based organizations here in New York City to do both mobile monitoring and fixed monitoring. We teamed up with the city's Department of Health and Mental Hygiene and Queens College to do some of the fixed monitoring and also work with the communities. And it's something I'm really proud of. It represents years of work, close collaboration between the city, not-for-profit organizations, community-based organizations, and it really goes all the way from here's how we trained young people to go out and take measurements. Here's how we decided to deploy instruments within the networks, within the neighborhoods that we selected. And then it connects the dots all the way through to, and here are the facilities that we believe are responsible for some of these higher emissions exposures. And here are the specific policy recommendations that these community-based organizations are looking to advance in New York City. So for instance, if I could share my screen just briefly. At any rate, one of the things I wanted to show you was like some of the specific facilities in the South Bronx. So for instance, there's a Hunts Point Food Distribution Center, which is one of the largest food distribution centers in the world. I think it might be the largest in North America. And so you've got hundreds of trucks coming into this facility every day. And so some of the recommendations were around electrifying vehicles that are coming in, moving to have refrigerated trucks that can plug in once they dock when they're unloading and loading. So definitely have a look. Let me know if you have any questions, and I'll hand it off.
Awesome. Thanks, Michael. Lauren?
Sure. Hi, everyone. I'm Lauren, a data scientist at Environmental Defense Fund, or EDF, which is an organization focused on environmental issues in 5 key areas. We do climate, energy, ecosystems, health, and oceans. In the health area, we've been a leader in deploying dense, lower cost and mobile monitoring networks in cities from San Francisco all the way to London. And in each of these projects, we've partnered with local leading health and science experts. So as a specific example, I can tell you a little bit more about the Breathe London project, which we launched in 2018, along with the Mayor of London, C40, leading academic and industry partners. And this project aim to advance both the science of hyperlocal monitoring and also to help people better understand their local air quality. So we combine both fixed and mobile monitoring, and as well as new data analytics to map air pollution across London. We measured fine particulates, nitrogen oxides, also carbon dioxide, which was a novel measure. And the network had 100 lower cost stationary monitors and 2 Google Street View cars, which were actually equipped with reference grade monitors, but we considered these non-reference or research grade because mobile is kind of an atypical configuration for those instruments. So you'll find that data in our in the low cost part of the OpenAQ platform. So the outcomes of the Breathe London project include that we built probably one of the world's most comprehensive networks of its kind, and the data that it provided allowed us to make both scientific advances and policy insights. So that included things like improving calibration methods for low-cost sensors, as well as techniques for addressing the increased uncertainty in that kind of data. And we even could use the data to evaluate a new policy in place in London called the ultra-low emission zone, which was implemented during the monitoring period of that pilot. So you can hear my dog. And finally, another important outcome I'll just mention from that project is that we did gather all of our experience and findings into a guide and a technical report that we are calling a blueprint for other cities to help them use lower cost monitoring techniques. So if you're interested in learning more, that is a publicly available report.
Great, thanks, Lauren. Albert?
Hi. So I'm a professor at Carnegie Mellon University, and we've been working with low-cost sensors in my group as far back as 2013. And so since about 2016, we've maintained a network of low-cost sensors around Pittsburgh. And we sort of started there partly because it's easy to do this in your backyard than trying to do it somewhere else. And partly because there's a lot of community interest in air quality in Pittsburgh. There's sort of a pretty long history of, sort of community groups and sort of air quality activism. And so some of our funding came from local foundations that were interested in trying to support what these various community groups were doing. And so a lot of the places, at one point, our network in Pittsburgh got up to 50 nodes running simultaneously. And a lot of them were places where sort of the community members or these community groups asked us to get set up, right? So they wanted to be near a particular source or in a particular community or at a school or something like that. And so we've been sort of running that network now for 5 years, and sort of our approach is that we have a sort of set of core locations, and then we have another set of sensors that we sort of cycle around for different, sort of special purposes, sort of monitor a neighborhood for 1 year, or, we did some baselining before this big new industrial facility is supposed to open, and we'll go back once it opens later this year. And so I think having that data is valuable to the community, and then we work really hard to try and make sure that the community can then get that data in a way that isn't reliant on them emailing me and waiting for me, because I would be the rate limiting step in getting it out. And then more recently, we've looked into sort of other ways to use these sensors. I saw some of attendees are from places in the global south, and some of our more recent projects are looking at, can we use low-cost sensors to supplement or to, in some cases, provide any monitoring at all in places in sub-Saharan Africa and South Asia where there isn't any monitoring. And so we're involved in a couple of projects to sort of do capacity building that would include deploying low-cost sensors, but also sort of doing, training of the local workforce to sort of be able to deploy the sensors themselves and use the data in sort of making decisions.
Great, thank you, Albert. Cindy, would love to hear from you.
Okay, thank you. Sorry, my dog was barking as she heard the dog on coming over my speaker. So Adrian is on, and he said, go ahead and I'll start this, and then he can jump in. I'm the CFO, so I'm probably not the best person to talk about this, but our goal is to really facilitate social change through the availability of information on air quality data. We want to allow the public to use that data for little or no charge, and that continues to be the direction that we're headed. We want to be able to give folks the knowledge of air quality for them to make good decisions for their own health. And we want to engage with as many local and global organizations as possible to get this information out to people. So that's the direction that we're headed. And then I'll ask Adrian if he wants to jump in. Are you there, Adrian?
All right, yes, can you hear me?
Yes.
Okay, what Cindy said is perfect. It's the mission statement of Purple Air pretty much. And we have about 12,000 sensors throughout the world now. In fact, I think it's actually more like 16,000 now. So we're growing pretty quickly, and we're excited to see the interest it's generating.
Great, thank you. As you all know, we shared from our side, from OpenAQ side, sort of our motivation for developing the OpenAQ platform. I'm wondering if you'd all be able to also share the motivation from your institutional organizations for actually sharing the data onto the OpenAQ platform. Would love to start with you, Lauren, just given that we were close collaborators on actually developing the pilot.
Yes, we were. And our motivation is that making the data that we generate free and open to everyone is essential. And we had known about the work of OpenAQ for a long time, but until now, the platform was designed for streaming data from regulatory and also stationary nodes. So a couple of years ago, EDF created our own platform, which was dedicated exclusively to low-cost sensor data because we were generating a large amount of that kind of data. And this platform was called the Air Quality Data Commons, or AQDC. But we started to realize that we needed a longer-term plan for that data access, and that a union of our user group with the OpenAQ user group into one platform and also one API. I think we always found the API at OpenAQ very impressive and beneficial, that it would benefit both groups. And so with OpenAQ, EDF formed a partnership that piloted this integration of low-cost sensor data and leveraged EDF's past experience making that publicly available into the OpenAQ platform. And so now our data sets actually make up a large number of the low-cost data that's available through the pilot.
Great, thank you. Albert?
Right. So, I think, as I mentioned when I was talking about sort of our, some of our community partners, like getting the data to them in a way that they can use it, I think is pretty important to us. And we found that takes multiple forms, right? Some of that is, obviously making data directly available. And then there are, sort of processed data products that people want to use. And so what we found is that different community groups, different users have different needs and different requirements. And so the more ways that we can share our data, the better. And then I think more broadly, like, it's not super helpful. Like part of the whole idea of having lots of low-cost sensors is you can have lots of data, and it's not super helpful if all my data is siloed in one place and someone else's data is siloed in another place, right? Having sort of common data formats and common repositories is really important to sort of, really see the value in having all of these networks out there.
Great, thank you, Albert. And it's very, encouraging to hear from you and Lauren about, especially from a research perspective, the importance of actually dismantling those silos and really being able to provide the data collectively and openly. Michael, you've been engaged very closely with community activism and community groups. From your perspective, what was your motivation for adding the data onto the platform?
Well, I was very thankful for the emergence of OpenAQ as an organization, the work that you're doing. Prior to OpenAQ pulling in our low-cost sensor data, we started pulling in your reference grade data using your API, and have had a great time working with your team, and have found that data inside of our platform has been valuable to people. As an organization, at our core, we're dedicated to open source. So we were excited to have OpenAQ approach us and say, we want to pull in your data. And I remember when the AQDC was being developed by EDF, we also wanted to get involved there and share our data through that platform. I kind of see it as, every day you open up your phone and you probably, one of the first things you might do is look at your weather app and check what the weather is going to be. And I think that's going to be the case increasingly going forward with air quality data too, where it's just a piece of information that everybody looks at every day, just like they look at the temperature or whether it's going to rain. Weather predictions, as air quality predictions, they get better the more historical data you have. And you can build better models and you combine those with your current observations, and then we can see what's going to happen in the future with greater accuracy. So I very much view the organization HabitatMap as looking to advance that goal. And we advance that goal by sharing data, making it widely available, making it intercompatible. And so I was really excited to have the AirBeam data and the HabitatMap aircasting data be pulled into OpenAQ's new low-cost sensor data pilot.
Great, thanks so much, Michael. And Cindy and Adrian, we all know purple air sensors have been proliferating across the globe. Would love to hear from both of you the motivation behind adding the data onto the OpenAQ platform.
The motivation behind adding it onto the OpenAQ platform was really you guys came to us and wanted to consume the data. So we've also understand the importance of sharing it with a wide audience. There are some little details that still have to be ironed out with these types of distributions, which is commercial use of that data. And so that's like a little bit of a difficult thing to think of how to deal with. But sharing the data with more people is indeed our mission. And OpenAQ does help with that.
Great, thank you. Would love to hear from all of you now, sort of thinking about now that the data is available on the OpenAQ platform, and as new users come to visit the platform and use and access the data, use it for their various projects and various initiatives. What do you see as the potential impacts of this aggregated and harmonized platform that's really collectively bringing all these data points together and making it accessible versus more siloed approaches or other sort of separate approaches of sharing data? Adrian, would love to start with you.
Well, the benefits of the harmonized approach, it is a good thing to be able to collect data or get data from multiple sources in one location. It does have some challenges in that the type of data is very different. If you compare the different low-cost sensor networks to each other, they've got different characteristics, different types of performance. And so one of the major things that people must bear in mind with harmonized or combining data into one platform is to understand those differences. You cannot compare one low-cost sensor network to another directly without understanding its behavior. And to sites like the South Coast AQ Spec program, where they've got all of the reports for the evaluations on there, is a very valuable resource to help to understand that type of aspect of it. but you must understand the differences. So that's why it's also important for a site like OpenAQ to be very, very transparent and very clear on the data source. The difference between Purple Air or other low-cost sensor manufacturers versus the regulatory, and being able to identify those different sources very clearly and very openly.
Great, thank you. Albert?
So I think one of the sort of the, themes of maybe like the next decade of air quality regulation, at least in the sort of the US, will be equity and environmental justice. And I think there's been a lot of good work on that using sort of regulatory data, but there are definite blind spots to the regulatory data, and sort of having that combined with various low-cost sensor networks can really enable people to sort of look at environmental justice questions sort of at a national scale in a way they haven't been able to before. And whether they want to think about that nationally or locally, this is a tool that can enable that.
Great, thanks, Albert. Lauren?
Sure. So actually, adding to what Albert's saying, I think another benefit is that it provides a platform for those who might have limited resources to host their own data. So there's an equity element there. And building on what Adrian said, I couldn't agree more. The low-cost sensor data has to be treated really carefully, especially if you're trying to compare different kinds of sensors. And I actually think that the harmonized data model that came out of the pilot, which now includes options for metadata parameters, does allow for that greater transparency. And it's all in one place now. So it can help you document the source, what kinds of instruments you're using, any post-processing steps that were or weren't taken. And all of that improves the scientific integrity and rigor, which is especially important for this data from low-cost sensors, which we know is kind of inherently more uncertain.
Thanks, Lauren. Michael?
I think the advantage of having everything on a single platform, the data harmonized, is one thing. I think when I look at what's happening with the data pilot, it's clear, like Adrian mentioned, there's still a lot of work to be done in terms of harmonizing. When we're dealing with different instruments, different networks, different, there's just so much variation that harmonization with so much diversity is a huge challenge. And then you have the additional challenge of, well, that's not really all the data we're interested in. We're interested in air quality data from low-cost sensors, from reference grade instruments. We're also interested in land use data. What kind of facilities are in the area? Are there parks there? What are the street trees? What's the street tree density? What's happening with the weather? So at a fundamental, it's you have an observation, it's an air quality measurement, and you're trying to connect it with other air quality measurements, with what's happening in the environment, with what the underlying health of the community is. And so I see it as a way of trying to connect all these dots together. And I see the development of this is going to be driven not so much just by putting everything into one platform, because so much of the challenge is making sense of the data. So I think the next phase in this is going to be not only about the harmonization of the data, which is great for people who are kind of higher level, more technical users, but then really trying to give some sort of data visualization, data analysis that's easy to access, that harmonizes the data before they merge, and yields results that aren't a black box at the end of the process. And so that's why I think this OpenAQ, this open source element of it is really important, because what I see happening, especially with some of the private ventures that are doing this, is that at the end of the day, they have something that looks really nice, but I can't make sense of all of the work that went into creating that nice visualization or that beautiful analysis. So I see this as really kind of an exciting kind of first step that OpenAQ is doing.
Awesome, thank you. Yeah, it's helpful to hear all of your perspectives on particularly the data access piece and how the platform can help to enhance that. On the data transparency piece, this is kind of a two-part question. What do you see as some of the barriers within the air quality data ecosystem that prevents organizations or companies from sharing data openly? And how do you think you can encourage your collaborators and competitors to join us in making low-cost sensor data sharing transparent? Lauren?
I think providers are concerned for a variety of reasons about their privacy. There can be regulations or even politics that cause them to keep it private. In other cases, even with researchers who want to keep the data private until it's thoroughly quality controlled, just to make sure that it's used responsibly. And there can also be technical barriers where an organization might not have the resources to prepare and manage and host the data to the point where they feel like they can make it public. In terms of how to encourage people, I think continuing to develop and improve the platform and provide more features that help get that data and scientific integrity out there. Some features also that have been mentioned already, might include expanding the visualization analysis tools and allowing people to access the data who maybe don't have a lot of programming experience or aren't very comfortable using an API. They can still get some insights by using the web interface. I'll stop there.
Great, thanks, Lauren. Albert?
Yeah, I think Lauren gave a really good overview of some of the barriers. I mean, I would add one maybe from a researcher's perspective is that maybe they want to keep it close to the vest until they get it published, which is an unfortunate sort of thing that happens in academic research. I think and then as far as sort of reducing the barriers, I mean, one thing that I think is, there a couple comments have been about sort of the harmonized data standard, and also sort of talking about the quality of the data and sort of making sure people are aware of that. I think those are things that, that having a common data standard is something that makes people more comfortable about putting their data online or putting it in an open repository so that they, so I think features like that do encourage people to make their data available.
Great, thank you. Michael?
I'm not sure from a commercial's perspective, because I think that's one of the big challenges, and Adrian kind of alluded to that, is that many of the folks the businesses that are involved in this sector have concerted interest in the commercialization of the data, and that in some instances they may be selling the instruments not as a profit-making center, but as a means to then selling software as a service. And so I think there are major barriers in that sense. And I'm not sure how you incentivize a for-profit company to share data on something like OpenAQ. I'd say for other folks, one of the things that I think is going to really drive the use of something like OpenAQ is this easy ability to basically collect data, dump it into something like OpenAQ's low-cost sensor data pilot, and get out some kind of output, data analysis output, whether it be averages for the month of July, or hot spots or hot times, because essentially then you're providing a service that they can't get otherwise, either through whatever platform they're using, or maybe they're just using, these are data pipelines, so maybe they just have an instrument but they don't have a back end, or maybe they have a back end but they don't have any data analysis engine. So I think that if OpenAQ can provide those additional resources, I think that will motivate people to dump their data into it, because then they can get that benefit out of it.
Great, thank you, Michael. Adrian, would love to hear from you from private sector perspective on this question.
Yeah, I think my limited understanding of this type of subject is that classically or typically in the past, companies like us that collect data see it as their lifeblood, as their revenue stream. And so sharing it openly is not really easy to do, because they fear that they would lose a revenue stream. So we have a pretty significant challenge in sharing data openly, yet also being able to afford to survive. So you got to know that hosting, and I'm sure the OpenAQ understands this very clearly, that hosting large quantities of data is a very expensive exercise, and then providing it free is almost like giving away what you're spending a lot of money in doing. So we have to figure out ways of generating revenue streams from the data while still making it available to the public for the uses like wildfires. The communities in California and Australia with wildfires really need this type of data. So we have to at the same time figure out how to monetize it. And that's why when we talk about purple air data on OpenAQ, we're talking about or mentioning things like non-commercial use, or if there's a commercial use of it, we have to understand and manage that process, because there are companies out there that want to, just scrape and take data from everywhere and then sell a very expensive product, and basically benefit off all of our really hard work. This is a very extremely complex, it's a hard work exercise to do. Purple air is it's quite a thing to run the whole network. So we want to try to make sure that we have the ability to survive, to pay our bills, and to grow.
Great, thank you so much. The final question is really kind of wrapping up on thinking about the trajectory of low-cost sensors. How should we be thinking about low-cost sensor data and the possibilities with the sensor networks moving forward? Albert, would love to hear from your perspective, especially given that you've worked in the research realm. I think that you have a particular angle, especially working on various projects within the research ecosystem, as well as community engagement as well.
Yeah. So hopefully this doesn't end up sounding too soapboxy. I mean, I feel like at this point, a lot of people have spent a lot of time figuring out how good these sensors are and what they can and can't do. But we still hear a lot of feedback of just like instantly people are like, well, is low cost is no good, right? And so, what I'd like people to know is that, we understand how well these sensors work. And then we sort of, once you know that, then you can know what they can and can't be used for, right? And so I feel like those are things that are understood. And there are certain questions that you definitely can answer with this. And there are certain sort of pieces of evidence you can bring with low cost sensors that you can use to either, convince a lawmaker or convince your neighbors or something, right? And it's not just all sort of like garbage in, garbage out.
Thanks, Albert. Michael, any things to share around low-cost sensors moving forward?
Something I try to keep in mind is that the ultimate output for this is, a young person learns about air quality in their community and how it's impacting their brother who has asthma. The community-based organization is able to present a map or a graph to an elected official to argue on behalf of a specific policy. So, you're doing all this work, but the end product is that someone changes their mind, someone learns something. And so I think we have to keep that in mind as we're moving forward, is that, there is, like Albert said, sometimes there's an obsession with, I guess there's just a lot of people engaged in the field, and there does seem to be a lot of emphasis on the limits of the instruments and all these things. And I think it's important to think of it as not as like there's one instrument in the field that's taking a measurement and we have to validate that single instrument. It's really about how you're stitching together the data, and that one instrument might not be so great, but if it's an entire network of instruments, all of a sudden you could make sense of that data in a way you couldn't previously. You could QA, quality assurance, and quality check it in a way you couldn't. Well, what if we combine that with reference data? And like before I was saying, what if we combine it with health data about what's happening in the neighborhood and land use data about what's happening in the neighborhood? And so I think we need to keep in mind that if we're going to move this forward, the ultimate application is someone learning something, changing something about their neighborhood or their community. And so we have to be delivering that. That's the thing we have to do, teach people how to use these tools to get to whatever their end goal is.
Awesome, thank you, Michael. Lauren?
Yes, definitely have the same thoughts about quality control and assurance, and making it easier for users to make these judgments about what is an appropriate use and what kind of comparisons are scientifically valid across locations or different networks, and allowing what is possible or similar to what is possible with reference grade data by kind of including that transparency. And another thing I think hasn't been mentioned yet is with versioning of data as well. Data, it's not static. Actually, in my experience in London, working with our mobile data and conducting the post-processing, which is an enormous effort, I think we actually went through about 8 different versions of this data set before what is ultimately available now on OpenAQ. So making sure that a data provider can update their data, but to do so transparently so that it's not suspicious. And, that I think that will encourage providers to add their data, having that ability.
Thank you, Lauren. Adrian?
Yes, so it's a couple of interesting comments already. The first one that I can add to is the tech comment about not trusting low-cost sensors. It's rather like back in the day, if the people sitting in a room full of computers, a supercomputer back in the day in the 50s that was the size of a building, would say, oh, well, you can't trust a small cell phone size supercomputer because it's too small, you can't trust it. That's not true. As technology develops, people will learn to trust them by using them, by having good experiences with them. That's why the experience and the trust in the technology is very important with testing and validating the data. Versioning is a great comment because on top of versioning, which version of sensor generated the data? Has there been any changes to how that's averaged or other types of key changes to how the developer might have modified his code for whatever reason? On top of that, even if you have a constant version of data, things change from moment to moment. The next moment there's an insect inside the sensor. Oh, and then the insect's gone again. So you have to almost do real-time validation. You can't just say this sensor is good, so therefore today's data is great. Every single packet that comes in must be validated. You must look at it in certain ways to determine that insect or that spider web that's inside there. The impact on people's lives is immense. We get told all the time how we're helping people to manage their child's asthma better, or with the wildfires, people are deciding where to go for the day. They're deciding if the air inside their house is good, if the air cleaner is working or not. So we know that we make a real difference in people's lives, and that's a great thing. So, the numbers of sensors is another thing. The more that you have out there, it becomes undeniable. When you have 1,000 sensors all reading in unison and showing the clouds of smoke coming across California, it becomes very, very compelling. So that's what's on our side, is the low-cost nature of it gives us the ability to roll out thousands and tens of thousands, which really becomes incredibly compelling. And the lawmakers and other doubters who might be out there will find it harder to deny the data in the future.
Great, thank you so much. This has been really inspiring and very hopeful in terms of the possibilities with low-cost sensors, as well as the OpenAQ platform pilot as well. I wanted to have a quick reminder in case the pop-up didn't come up. Would love to get your feedback on the poll on low-cost sensors. This will be really helpful for us as a team to really enhance the pilot and enhance our work overall as we engage with low-cost sensors moving forward. This is also a reminder that the webinar recording will be available on the OpenAQ YouTube channel, which will circulate to all registered participants. If you haven't already done so, please take a moment. It should take only 10 minutes to complete the OpenAQ community survey. This will help inform the new tools and enhancements on the platform that we'll be developing this year. And we'll be in touch and post updates on Slack in our newsletter and on LinkedIn. So we'll share those links as well and circulate them by email. Thank you all so much for joining. Really appreciate the panelists, Albert, Michael, Lauren, Adrian, and Cindy. Thank you so much for sharing your insights today. And wanted to also thank our sponsors and our supporters, Bloomberg Philanthropies Clean Air Fund, ClimateWorks Foundation, and the Environmental Defense Fund for making our work possible. So thank you all so much. Please stay safe and healthy, and we're very excited to stay in touch. Take good care.
Thank you.
Thank you.